Hello, welcome to our first lecture, Introduction to Earth Science. In this lecture, I will summarize most of what is covered in more detail in Chapter 1 of your textbook. Your main learning objectives are to get a sense of what Earth science is, specifically list and describe each of the 4 branches of Earth science, to get a sense of the scientific method, and to be able to demonstrate each of the steps involved in the scientific method. And there are other parts of this lecture that you need to know as well, but the 2 SLOs listed are the big picture ideas. Earth science. Earth science includes the study of 4 natural components that make up and surround planet Earth: geology, meteorology, oceanography, and astronomy. Geology is the study of the solid Earth and the materials and processes that make and shape its surface. Meteorology is the study of the gas component of Earth, or atmosphere, and the composition and processes that operate within the atmosphere. Oceanography is the study of the composition and processes of the oceans, as well as the topography of the sea floor and the interaction of the ocean with the shorelines. Astronomy is the study of the universe. In this course, we're going to narrow that study down to just our solar system. Here we have a geologic process in action: lava flowing into the ocean and solidifying into rock. An earthquake is another example of a geologic process. This photograph shows the aftermath of a strong earthquake that recently happened in Central America. Here we have a landslide. Landslides and earthquakes both can happen suddenly and without warning, and can be considered natural disasters when they negatively impact people. It's for this reason that earth scientists study these natural phenomena. We want to better understand them so we can make predictions and save lives. Earth is made of rock, so earth scientists study the rock of Earth's crust, like the cliffs we see here at the Grand Canyon. Oceanography being the study of oceans. One area that is of particular interest for earth scientists are where the ocean and the land interact along the coasts. Here we have waves crashing on the shore. The landscape being changed by the process of the ocean interacting with the land is one that could potentially affect people. So again, it is of interest to earth scientists. Smog negatively affects humans. So this atmospheric condition is studied by atmospheric scientists like meteorologists. Tornadoes are studied by meteorologists as well. They occur in the atmosphere, and this atmospheric-based natural disaster is one that, of course, can negatively affect humans. By studying tornadoes, hurricanes, and other such atmospheric processes, we can make better predictions about when and where they'll happen, and in doing so, save lives. By studying objects outside of our planet, we can better understand Earth. Because the material that makes up our solar system, galaxy, and universe are ultimately made of the same things that Earth is. Such as atoms and elements. So in this illustration here, we have the Milky Way galaxy, in which our solar system is contained. Earth is contained within our solar system. Earth's continents are comprised of landforms such as mountains, which are made of rock. Rock is made of minerals. Minerals are made of the atoms of the elements that we find not only here on Earth, but in the universe beyond. Our solar system formed about 4.6 billion years ago. This is a huge amount of time, and as human beings that live only 100 years, if we are lucky, billions of years is very challenging for us to conceptualize. To help put 4.6 billion years into perspective, let's compress this history of Earth and our solar system into a calendar year, with January 1st, just after midnight, being the origin of Earth, and December 31st at midnight being this moment. Looking at the calendar here, here's our origin of Earth. We go to early mid-February, we have the oldest known rocks that exist on Earth's surface. Those are about 4 billion years old. The earliest evidence of any life doesn't show up until near the end of March. This would be simple single-cell microscopic organisms. We continue through our calendar: April, May, June, July, August, September, October, and we don't get until mid-November until we have animals with hard parts becoming abundant. So this is important because this is when organisms begin to resemble something like they look today. In particular, these organisms had shells in the sea. It's not until the very end of November that plants and animals actually exist on land. So if you can consider that, all of November, October, September, August, all the way back to the beginning of the year. So for 11 months of our history out of 12, there was nothing on land, just rock, completely barren, no greenery, no animals until the end of November. Then we get into December, and we break this down into some more detail. We see the days of December. From December 15th through the 26th, dinosaurs dominate the land. So the dinosaurs were a very successful species, existing for close to 200 million years. We move now to December 31st, the last day on the calendar year. We have some different times outlined here. Let's look at this. December 31st, 11:49 p.m., humans, Homo sapiens, appear. So we're not around until the very last 11 minutes of the entire year. Our ice age, our most recent ice age, glaciers recede from the Great Lakes at 11:58 and 45 seconds, so 15 seconds before midnight. December 31st, 11:59 and 45 seconds to 11:59 and 50 seconds, Rome rules the Western world. So the Roman Empire, the longest existing empire, is around for 5 seconds on this time scale. Columbus arrives in the New World at 3 seconds to midnight. And then, as I mentioned before, this very moment is right at midnight. So on this calendar, our life, 100 years if we're lucky, is less than a second. So earth science and the sciences contained within this subject, geology, meteorology, astronomy, and oceanography, are studied by scientists, and the study in science is done through a orderly but natural process that we call scientific inquiry. This is also known as the scientific method. This refers to the steps that people use to construct predictable and repeatable explanations about the workings of the world around us. This process can start with an observation and or question about a particular phenomenon. Perhaps there's something out of the ordinary that we observe, maybe in our everyday lives, or maybe in a more scientific setting. This is naturally followed by the desire to explain what is happening. This reasonable explanation is called a hypothesis. Hypothesis is sometimes called an educated guess. In order to determine if the hypothesis is correct or valid, it must be tested. And this is done through collecting data. The data is then analyzed to determine if it supports the hypothesis. If so, then it would advance to the greater scientific community for further scrutiny. This may take years, even decades of time, in order for enough testing, enough people to analyze the testing, enough people to discuss the testing, before the hypothesis is fully accepted by the global scientific community. If it gets to that point, and all the testing supports the hypothesis, then we can go to step 5, which is a theory. A theory is a very certain explanation for the phenomenon. Something that's been tested, retested, and is not debated by anyone. We leave the possibility that in the future, with different testing methods, with different technology, with different discoveries, we may modify the theory. But the word theory in science refers to something that is very, very certain and is agreed upon by all scientists. If instead the results of our testing and analysis did not support the hypothesis, then the hypothesis needs to be reevaluated or perhaps scrapped altogether. So here we have a series of photographs representing some examples of how scientists collect data using technology, hands-on using manual tools. This person's in a lab studying using a microscope. Scientific method practice. So in order to test your own understanding of the scientific method, I'd like you to imagine this scenario and work your way through it using the steps of the scientific method that we have just discussed. After entering a dark room, you turn on the light switch, but the light does not come on. Consider how these 5 steps of the scientific method would apply to this situation. Write down your answer and submit these answers to the discussion assignment, Scientific Method, which you can find on Canvas. So there are the steps outlined once again. I look forward to reading your discussion comments and see how you went about handling this scenario. That's the end of this lecture.